In this question, we are asked to analyze this quadratic function. And first of all, I want to remind you that we know this is a quadratic function because of its degree. The highest, the largest exponent of a variable here is a 2. So this is degree 2, which means that it is definitely going to be a quadratic function. So quadratics are degree 2. And we know from the parent function is y equals x squared. We know the basic shape of our quadratic functions is a parabola. Now, because we have a negative leading coefficient, we know that our parabola would open facing downwards. So the end behavior, the ends of the graph, both on the left and the right, are pointing down. And that means that we are going to end up with a point here at the top, which is the highest point on this graph, which is going to be a maximum. So we know for sure that this function will have a maximum because the parabola is facing downwards. The next two parts are asking for the actual maximum value and where the maximum occurs. So remember that this maximum is called the vertex. And when we are trying to find the vertex of a parabola by hand, we can use the vertex formula, which is the opposite of b divided by 2a, or negative b divided by 2a. So we need to go back to our quadratic function and identify a, b, and c. So a is our leading coefficient, which is negative 2. B is the coefficient of the x term, which is a positive 20. And c is the constant, the number that does not have a variable. In this case, that is negative 49. So x is equal to negative b, or the opposite of b, so that would be negative 20, divided by 2 times a, 2 times negative 2, which is negative 20 divided by negative 4, which will give us positive 5. Now remember, this is the x-coordinate of the vertex. So we know the vertex occurs at 5, some value, and we don't know the y value. We don't know the output. So we need to substitute 5 back into our function. In other words, we need to compute f of 5, which will be the y value, the output, when x is equal to 5. So the function was negative 2x squared, so we're substituting in positive 5 in place of x, plus 20x, so that would be 20 times 5, minus 49, and this will generate our output, or our y value. 5 squared is 25, 20 times 5 is 100, so we have negative 50 plus 100 minus 49. Negative 50 plus 100 is positive 50, and positive 50 minus 49 is positive 1. So that means that the y value of our vertex here is positive 1. So what is the function's maximum value? Here it's asking you for the y value, which is the largest y value over that entire graph. So that's going to be positive 1. And then where does the maximum occur? This is asking you for an x value. Where does it occur? That's the x value of the vertex. So in this case, it would be x is equal to 5.